Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so this video is to cover for vector product, or also known as the cross product. Okay, so in vector product, let's say if we have two vector, which is the vector A and this is a vector B. Okay, so when we do a cross product between vector A and vector B, so let's say we have vector A cross B, so then we will have a vector that will be in the direction of downward like this. Okay, so how to determine whether your vector of A cross B will be towards downward or upward is to follow the right hand grip rule. Okay, you can put your thumb on the diagram, and then you can follow that the A go to B. Okay, so you can grip your hand and then from A to vector B, and then your thumb will be pointing towards the direction of A cross B. And then if you do a vector for B cross A, okay, B cross A, so then you will have a vector in this direction. This is for B cross A. Alright, so I don't know why this whiteboard just suddenly get updated this morning, so I don't quite like it. So it looks quite weird to me. Okay, so this is about the vector product. And so the formula to do a vector product is A cross B will be equal to magnitude of A multiplied with magnitude of B sine theta n. Okay, what is this n? Okay, n is the unit vector. Okay, n is the unit vector for the resultant vector that we obtain after the cross product. For example, this one, AB. Okay, and this magnitude of A multiplied with magnitude of B sine theta will become the magnitude for this unit vector. Okay, so the vector that has been produced of B cross A and A cross B will always be 90 degree to the plane of vector A and B. So let's say we have these two vector AB, so it will create one plane like a single sheet of paper, and then the B cross A is the 90 degree towards that plane. Okay, so if we calculate the magnitude of A cross B, so A cross B magnitude will be equal to magnitude of A, magnitude of B sine theta only, because the unit vector, when you do the magnitude for unit vector, it will be equal to 1. Okay, so as you know, since I already show you that A cross B will not be equal to B cross A, but A cross B will be equal to negative B cross A. Okay, so let's look at this example. We want to find the vector that is normal to plane A equal to I minus 2j plus 3k and B equal to negative 2i plus 3j plus 2k. Alright, so we have a plane of vector that is vector A and vector B. So let's just create an example. This is vector A and this is vector B. So these two vectors will create a plane in between them like a piece of paper. Okay, and then the question wants a vector that is normal, so that will be 90 degree to the plane. So here will be the vector. Okay, or could also be like this. So the upward one will be a vector that is a B cross A, and a downward one is a vector for A cross B. Okay, so for this one, let's do for a vector B cross A. So B cross A is equal to, okay, so in order to do this kind of cross product, it can be done by changing these two vector into the form of matrices. Okay, so this is a IJK vector, so it will create a 3 by 3 matrix. So the first row will be the I, J and K only. Then the second row will be the first vector, that is B, negative 2, 3, 2. And the third row is the vector of A, 1, negative 2 and 3. Okay, so once we have changed it into the form of a matrix, so in order to find the B cross A, we have to solve it by like we solve for determinant for matrix. Okay, we solve it for determinant, and it will be, we choose the first row. So the first row with the I, negative 1, 1 plus 1, and then the minor 3, 2, negative 2, 3, plus J, negative 1, the 1 plus 2, then the minor, negative 2, 2, 1, 3, and then plus K, negative 1, 1 plus 3, and then the minor is negative 2, 3, 1, and negative 2. Okay, so then we solve this, it will be 9 plus 4 I minus negative 6 minus 2 J plus 4 minus 3 K. So then it will be 13I plus 8J plus K. Alright, so this is a new vector in the form of I, J, K. So this is the equation for vector B cross A that is facing upward, in the direction of upward. Okay, so you can try by yourself to find the vector for A cross B and check whether this A cross B is actually equal to negative B cross A. Okay, so this one I want you guys to try it by yourself. Okay, firstly you change the vector into the form of matrices. Okay, alright, the next example, okay, we still use the same vector of A and vector B. Okay, so now the question change to find 3A cross 2B. Okay, so in order to solve this one, so instead of multiplying the vector A with 3 and multiplying vector B with 2, and then you do cross product in between them and do the determinant process, and you find the vector of 3A cross 2B. So instead of using that method, you can just simplify this equation of 3A cross 2B. It will be equal to just as 6A cross B. Alright, it will be the same thing. So since you already have a vector of A cross B, so then you just multiply with 6. So 2I plus J plus 3K, and then your 3A cross 2B is equal to 12I plus 6J plus 18K. Okay, so the next example, use cross product to show that vector A and vector B are parallel. Okay, so now we refer back to the equation of cross product. If A cross B equal to magnitude sine theta unit vector n. Okay, As you can see right here, we have a sine theta. So this sine theta, if the two vectors are parallel, so that means your theta, which is the angle in between the vector A and B, is equal to 0 degree. So then your sine theta is equal to 0 degree. Sine 0 degree will be equal to 0. So for a parallel vector, there will be no cross product happen. Alright. So that's mean in order to show these two vectors are parallel, so we use the method of the determinant. So then we take A cross B. So we create the IJK, the matrix IJK. Then the second row is the vector of A, 2, -1, 4, -6, 3, and -12. So the determinant will be firstly the I, -1, 1 plus 1, -1, 4, 3, -12, plus J, -1, 1 plus 2, finally the K, alright. So then it will be the I is 12 minus 12 I plus, sorry, it will be the minus. So here is -24 plus 24 J and plus 6 minus 6 K. So here you can see it will be 0I minus 0J plus 0K. So it is equal to 0. So here means the A and B, A cross B, sorry, A and B are parallel. Okay, so next let's go to the application of cross product. Okay, so cross product can be used to calculate. The first thing is to calculate the area for parallelogram, and second is to calculate the area of triangle. Okay, so firstly let's look at about to calculate area for parallelogram. Okay, so let's say we have a parallelogram right here. Okay, so this is our parallelogram. Okay, so this parallelogram, let's say we have the side of parallelogram labeled as A, and right here is labeled as B. So based on the mathematical formula, the formula to calculate the area of parallelogram will be equal to the altitude of the parallelogram multiply with the length of the base of the parallelogram. So the altitude in this parallelogram is actually the vertical height of this parallelogram and multiply with the base length. So in terms of this diagram, the altitude is actually equal to the sine theta of B. So magnitude of B sine theta. So it will be equal to the opposite of the theta multiply with the length of the base, that is the A. So okay, so the area now can be equal to magnitude of A multiply with magnitude of B sine theta. Okay, as we can see, this equation is actually similar to the equation of cross product where we have magnitude of A cross B equal to magnitude of A, magnitude of B, sine theta. So this is how we can calculate the area of a parallelogram by using the cross product of a vector. Okay, now let's look at an example. We have these two vector of vector u and vector w given there is the equation. Okay, so these two vector is positioned like this, so it can create area that is similar to a parallelogram. So our task is to find the area of parallelogram created by these two vectors. Okay, so firstly let's label. So I want to label the pause point. So this is as point P, this is point Q, and this is as point R. So we have the PQ. So if we have PR, if you have PR cross PQ and find the magnitude, it will be equal to the area of the parallelogram. So in order to find this area of parallelogram, we firstly do the cross product by using the determinant method. Alright, so that will be PR cross PQ will be equal to the matrix IJK, and PR is 3, 1, 2, 1, negative 2, negative 2. Alright. So we do the method of determinant right here, and we will have I, negative 1, 1 plus 1, 1, 2, negative 2, negative 2. Then the J, then the minor, and then for K, okay, so here will be negative 2 plus 4 I minus negative 6 minus 2 J plus negative 6 minus 1 K. Alright, so we have the 2I, and here will be plus 8J minus 7K. So this is the equation of PR cross PQ. So the area of the parallelogram will be equal to the determinant of this vector. So the determinant is 2 square plus 8 square plus negative 7 square. And then it will be equal to square root of 117, or could also be written as 3 square root of 13. Okay, so this is the area of the parallelogram. So you indicates the unit square for the unit for area. Okay, so now let's continue with the second application of cross product, which is the area of triangle. Okay, so the situation is still the same where we have two vector. Let's say we have vector u and vector v. Okay, so these two vector will create an area of parallelogram just the way we have seen before. Okay, so this is the area of a parallelogram. Area for parallelogram is equal to magnitude of u cross v, right? Okay, so where is the triangle? So the triangle is actually the half of the parallelogram. So here is the triangle. So in order to calculate the area for triangle, so it will be equal to U cross V magnitude divided by 2. So that is the equation to calculate the area of triangle. Okay, now let's look at the example. Find the area of triangle in space with vertices A, B, and C. So we are given with the coordinate for vertices of the triangle. So let's first we draw the triangle. So let's say this is the triangle, and the vertices will be A, B, and C, where the coordinate of A is 0, 1, 3, 4, negative 1, 2, and C is 1, 3, and negative 5. So from these coordinates, we can create the vector. So we only need 2 vector to create to find the area of the triangle. So let's do the vector for B to A. So this is the BA. So the vector for BA will be the 0. 0, the x coordinate 0 minus 4. So that is negative 4i. So 1 minus negative 1 plus 2j. 3 minus 2 is plus 1k. So this is the vector for BA, and we create another vector which is the BC. So this is BC, and the vector equation for BC, 1 minus 4 is negative 3i. 3 minus negative 1 is plus 4j. And negative 5 minus 2 minus 7k. Alright, so these are the 2 vectors that we need to find the area of the triangle. Okay, so we know the area of the triangle is the BA cross BC magnitude divided by 2. So we first do BA cross BC, and I, J, K, negative 4, 2, 1. 4 and negative 7. And now we do for the determinant. Is the I, negative 1, 1 plus 1. Then the minor. Okay. So now we calculate the equation from the determinant. So we have negative 14 minus 4i plus, so this one will be a negative, and here will be 28 plus 3j, and negative 16 plus 6k. So it will be equal to negative 18i minus 31j, and here will be negative 10k. So that is the equation from the cross product. So then we find the magnitude. So magnitude is plus negative 31 square plus negative 10 square. So here equal to square root of 1385. Okay, so this is the area for the parallelogram, not the triangle. So area of the triangle, we mention that we take the area square root of 1385 and divide it by 2. So we put unit square. So this is the area of the triangle.